Assalamualaikum warahmatullahi wabarakatuh. So today me and my partner, Ms. Shafika, Nadia, Sabaudin. My name is Najura Zulkifli. We will explain about active filter or high pass filter. Active or high pass filter. First is the definition. A high pass filter will allow the frequencies which are higher than the cutoff frequency and attenuate the frequencies lower than the cutoff frequency. The amount of attenuation or the passband range will depend on the designing parameters of the filter. An active filter means that its circuit contains an active component such as transistor, operational amplifier, and etc. for better performance, but mainly for amplification. Okay. Next is the principle. So the basic operation of an active high pass filter is the same as for its equivalent RC passive high pass filter circuit, and the frequency response of the circuit is also the same as that of the passive filter, but except this time the circuit has an operational amplifier or included it as design, providing amplification and gain control. So for a non-inverting amplifier, the value of the passband voltage gain is given as 1 plus resistor 2 divided by resistor 1. Okay, so this is the example of active high pass filter for non-inverting. So this is the schematic circuit. So next, at low frequency, or when the operating frequency is less than the cutoff frequency, the voltage gain is less than the pass band gain, which is a max or AF. So next, at high frequency, or when the operating frequency is greater than the cutoff frequency, the voltage gain of the filter is equal to the pass band gain. And if the operating frequency is equal to the cutoff frequency, then the voltage gain of the filter is equal to 0.70 times by pass band gain. So this is the simplified picture for the above explanation. Okay, next, in frequency response of the active high pass filter, the maximum pass band frequency is limited by the bandwidth or the open loop characteristic of the operational amplifier. Due to this limitation, the active high pass filter response will appear like the wideband filter response. By using this operational amplifier based active high pass filter, we can achieve high accuracy with the use of low tolerance resistor and capacitors. Okay, next I would like to invite my friend Shafika.
Assalamualaikum. My name is Shafika Nadia binti Sabarudin. So this is example for formula active filter high pass filter. So for the number one is frequency cutoff. The formula is frequency cutoff equal to 1 over 2 pi RC time RC. So for number two, pass band gain. So this is a formula for pass band gain. AF equal to 1 plus R2 over R1. So 2 equal 1 plus R2 per R1 and R2 per R1 equal to 1. So number 3 is voltage gain. This is a formula for voltage gain. So AV stand for voltage gain equal to V out over V in, so equal to AF F over to FC divide over square root 1 plus F over FC square root. So the lastly is AV dB equal to 20 logs 10 V times V out over V in. So for characteristic graph is when we talk about cut-off frequency, we refer to the point in the frequency response of the filter where the gain is equal to 50% the peak gain of the signal. Example, 3 dB of the peak gain in high pass filter gain increase with n increase in frequency. So this cut-off frequency depends on R or C values of the circuit. Here time constant T equal to RC. The cut-off frequency is inverse proportional to the time constant. So for biomedical application is high pass filters attenuate the components of a signal below a certain frequency range. They help to remove lower frequency variation, possibly due to signals that are uninteresting in context from data. For example, you can remove the respiratory component from ECG by running the data through a 1 Hz high-pass filter either in hardware, a setting on the amplifier, or in software. Transform digital filter IIR high-pass. So the filter is center the signal around the zero line. So the cut-off frequency of the filter provides an indication of what frequencies are attenuated. So note that some energy at frequencies lower than the cut-off frequency will remain in the filter signal. So
Okay.
I pass back. I pass
Thank you.
back to Nazrul.
Thank you, Ms. Shafika. So next, I will do the simulation for the high pass filter using the sim. Okay. So this is the circuit for non-inverting active high pass filter. So why is it non-inverting? It is because that the input that will move in, the input signal will move into the positive, which is non-inverting. So this is the high pass filter component, and for this part of the resistor is for the amplifier gain. So this is the amplifier part. So the capacitor value is 10 nanofarad, and for the high pass filter resistor is 10 kilo ohm. And for the gain of the pass band gain, which is for the amplifier, is R1 is 10 kilo ohm and R2 is 100 kilo ohm. So this is the function generator, which we will create the signal wave, and this is the oscilloscope, which we want to measure the output signal and the input signal. And the operational amplifier that we use is 741. Okay. So first, we will look to the calculation. So there are three components in here involved the calculation. First is the cutoff frequency. So the cutoff frequency is that we put the value of the capacitor and resistor for the high pass filter, which is 10 kilo ohm and 10 nanofarad. And the cutoff frequency is 1.592 kilohertz. Next is the pass band gain. So this is the we insert the value for R2 and R1 plus with 1 divided R2 divided with R1 and plus 1. Thus the gain is 11. So the third calculation is voltage gain. So not in here. The input frequency that we will use for this experiment is 2 kilohertz. So we insert the value for the cutoff frequency and pass band gain inside this formula at F and FC with input frequency of 2 kilohertz. So the voltage gain is 8.6 gain for the circuit. Okay, now we will do the simulation. First, we look at the amplification, which we supposed to get the voltage gain, the amplification of voltage gain equal to 8 as 8.6 volt. Okay, so not in here. So this is the input frequency, as I said earlier, which is 2 kilohertz, and the amplitude we use is 1 voltage peak. Okay, so this is the output. Okay. Okay, now, so the green waveform is the input signal and the red waveform is the output signal. Why? Because you look at the wire. So this is the input, the green wire, and this is the output, which is the red wire. Okay, so now firstly we will measure the input signal. So it is 94362 millivolt, which is approximate to 1 volt amplitude. So next, we will change the trace for the output waveform. So now it's measuring the red waveform, which is, so that is the result for the amplification channel B, which is the output, which is 8.59, which is approximate to 8.6 voltage gain. So we have successfully amplified the signal from 1 volt to 8.6 volt. Okay. So now we will move to the frequency response of the circuit. Okay. So this is the frequency response for this non-inverting active high pass filter. It is a magnitude of decibel versus frequency on the y on the x-axis. So earlier that we calculated the frequency, the cutoff frequency is 1.59 kilohertz. Okay, so now focus on the x-axis for the cursor one, which is x1. So now we want to find the so first of all we will find the magnitude of decibel, which is when the pass band gain is at 11. since the maximum gain is 11, so we will calculate the value for the decibel, which is 20 log 10 of 11, which is equal to 20.83 decibel. So this is the maximum value it can go. So the closest one will be 20.67 decibel, which is at 12.01 kilohertz. Okay, so that is the maximum gain, which is 11. And now we will look at the cutoff frequency. Cutoff frequency is 1.59 kilohertz. Okay, there you go. X is equal to 1.58 kilohertz. So the decibel is 17.76. So if we minus from the 20.67 decibel to the 17.78 decibel, so we will get close to the negative 3 decibel. So the conclusion is that we have successfully created the circuit. So this is the simulation that we are trying to show. And then this is also related to the one that we presented just now, which is on this part. So it says here at a very high frequency, which is the input frequency. If the input frequency is better than cutoff frequency, like just now, maybe 12 kilohertz, so that we know that the voltage gain is will be equal or approximate to the passband gain, which is just now the passband gain is 11. So from the circuit, if you want to increase the gain, maybe more than 11, so maybe you should change the value of your R1 and R2 so that you will get a higher gain. Okay. So this is for the non-inverting rectified pass filter. So if you want to do the inverting rectified pass filter, the configuration will be different, which the input will be insert through the negative, which is inverting, and you should choose wisely your operational amplifier and your component value so that you will get the desired output for whatever your configuration you are trying to do. So that's all from us. Thank you very much.